Okay, I'm ready to record. I'm clean, I'm moisturized, and I'm painfully aware that I have a perfect face for radio. Thesis: your software development instincts want to build interfaces that can solve every possible problem, but by doing so, what you end up designing is just a worse version of the environment you were working on in the first place. That's the inner platform effect. Don't do that. Hi, I'm CubeDrone. I've been developing software professionally for over 15 years, and while I'm still not very good at it, I have a lot of opinions I'd like to share. But first, a word from our sponsor. Are you worried that people are spying on your behavior when you're using the internet? That bad actors are intercepting and de-anonymizing your web traffic to snoop on you? Well, there's a solution. Unplugging your computer. You don't need a VPN. Unless you're planning on pirating content or doing journalism from freedom-restricted countries like China, or to a lesser extent, the United States of America. If you don't plan on doing these things, don't get a VPN. Their business model works in essentially the same way a gym membership does. You think you'll use it, then you won't. And while you're not using a VPN, go to www.zombo.com and use code CubeDrone20 to get 20% off the money you're not spending. Are we back? Okay. This is a real example. A story from a long time ago, a real thing that I've actually seen happen. Names and details have been changed to protect the innocent. So a coworker, Grumbo, was working on a big project where they were growing frustrated with SQL. SQL, as you might know, is a full-featured query language that allows software to communicate back and forth with a database. One of the properties of SQL is that it forces its users to decide on the tabular structure of their data up front. Changes to the data structure call for changes to the underlying tabular structure. If, for example, you have a table that looks like ID, name, phone number, weight, and you want to add a new column, height, you must modify the table to support the height column before adding height data to each row. In order to present an interface to other developers that they could use without having to learn SQL, Grumbo thought that they would create a new kind of data store for the application, one that would act as a simple key value store. The key value table allowed users to put any serializable data into any key. Convenient, right? Now people working with the database didn't need to fuss with table definitions. They could just plop any data they wanted in there. Now here's where things start to go off the rails a little bit. Grumbo was a good software developer, the kind of person who thinks ahead and tries to build abstract interfaces that can serve any purpose. So they thought, what if developers want to divide their keys up into separate collections? If you're searching for, say, employees, you don't want account records showing up in your search. What if Grumbo were to include rules that allow developers to define a schema for their data? They can define the schema up front, and then the backend can automatically validate that the data matches the schema that has been defined. Convenient. Now, some of you might be noticing what's happening here. Grumbo was accidentally designing a database, and they were doing it on top of an existing database. If they had kept going, they might have started to add things like, relationships between data elements or indexes on specific rows in the data to make them easier to search. They might have even gone so far as to define a domain-specific language that would allow them to query the data without even having to write code. A structured query language. SQL. This is the inner platform effect at play, when software developers get so lost in the sauce that they accidentally build a smaller, crappier version of the thing they were working on in the first place. Like, say, for example, you're using the templating language PHP. PHP was initially designed to be a templating language, and as a result, on top of being an okay programming language, it's quite a versatile and powerful templating language. That doesn't stop people from building templating languages in PHP, at which point they're just running a simpler templating language inside a templating language. So why is this bad? Well, first of all, it's kind of a waste of time. SQL is already a perfectly good database. Using SQL to build a worse SQL accomplishes very little. I mean, it's a useful exercise. You get smarter by building more software, but at the end of the day, we don't ship software by building software that already exists. If SQL isn't what you want, if what you really want is a fast, open-ended, schemaless key-value storage provider, well, lots of those already exist and are battle-tested, production-ready databases that you can start using tomorrow. You don't have to build your own in SQL. On top of that, if you wanted to build a new database, maybe you want something totally new and unique for a kind of data that isn't really readily stored by existing databases, it would probably be better to build that from scratch without all of the overhead of a pre-existing database. There's pretty much no way to make the database that you write using SQL faster than the SQL you wrote it in. So why does this keep happening? I have a few theories. First of all, there's the software developer's natural desire to make every tool they build more abstract, more generalizable. There's a quote I'm very fond of. It should be noted that no ethically trained software engineer would ever consent to write a destroy Baghdad procedure. Basic professional ethics would instead require him to write a destroy city procedure, to which Baghdad could then be given as a parameter. While it's ethically indefensible to write a destroy Baghdad procedure, the joke here is that it's instead professionally indefensible because that's a less general API design. Now, I don't want to get too deep in the weeds with this argument, but in my opinion, this is a habit that can easily go too far. When you're first learning how to go from a junior programmer to an intermediate programmer, part of that journey is discovering all of the techniques you can use to reduce code duplication, increase modularity, and generally make your software more abstract. These tools should not be used indiscriminately, because the goal of most system design is not to make the most perfect, most general, most abstract, most modular system. That system already exists. It is the programming language you're building the product in. Your goal is to take that and make specific, concrete, non-abstract design decisions with it. That's what a product is. You're probably not building a platform. You're building a product, so don't make your API too general. Another theory for why this might happen, write-only programmers. It's, in my opinion, for many developers, easier to write a completely new product than it is to learn how an existing product works. It's easier to write code than it is to read code. Honestly, it's a better learning experience too. I don't think you're fully equipped to really understand how an existing system works until you've tried to build something similar and discovered all of the weird pitfalls that their system designers had to work around. But building ambitious new reimplementations of existing functionality as a learning exercise is probably not your job. So, is this always bad? Sometimes inner platforms can be very useful, and many systems that could easily be described as inner platforms are widely used today. One common reason, is to introduce the kind of security layer that applications often need. JavaScript in the browser is an inner platform. It's running on C++, a different underlying programming language, because it is a scripting language that runs in a very locked-down sandbox. I can write code that executes on your computer using only JavaScript, but the strong security guarantees provided by the inner platform make it much safer, even if I'm a malicious actor, which I definitely am. GraphQL is another example. It's a query language intended to run in the application layer. Under the hood, a service running GraphQL may very well be providing its data using SQL, but it wouldn't make sense to provide direct access to the SQL to your clients because that's honestly too much power for the clients to have access to. VRChat provides an inner platform. Udon, a sandbox scripting environment built in C# because we can't have players just passing around C# and executing that. That's dangerous. Another benefit of an inner platform is if you implement the same inner platform identically on a variety of outer platforms. It becomes a compatibility layer. The code you write for the abstracted inner platform will then work reliably across a variety of systems. A sufficiently advanced inner platform becomes just a platform, which is a good thing to have developed if, and only if, you need one. If you don't, less code is usually better. Have you encountered an unnecessary inner platform? I want to hear stories of the unnecessary inner platforms you and your coworkers have built. I know you've got them, so please chime in. So, your software development instincts want to build interfaces that can solve every possible problem. But by doing so, what you end up designing is just a worse version of the environment you were working on in the first place. That's the inner platform effect. Don't do that.